Poppit the robot is stranded on planet X, and she must find her way home. First, she is low on power and must pick up a new arc reactor, located in the corner of the maze. She must then carry the reactor to a charge dock, charge it, and navigate to a blast-off station. Poppit is equipped with an Arduino board that controls both actuation and sensing. She moves with a differential drive system on her two rear wheels and can operate a third servo motor to control the position of her sonar sensor. Poppit detects the maze around her using sensor fusion between sonar and an IR rangefinder, as well as her internal odometry. The IR rangefinder is used for wall following and turning at a fixed radius. While following the wall, Poppit periodically checks for a wall ahead of her using her sonar sensor. She has some knowledge of the maze structure, and that she knows which way to turn when she sees a given sequence of walls. But Poppit does not know how far apart walls are, and therefore must do all of that sensing and decision-making online. To reduce noise from her sensors, Poppit averages sensor input and only accepts values that are reasonable, given her internal model of the world. She has now reached the arc reactor pickup point, and will turn around and then head across the maze to the charge station. To reach the charge station, Poppit must navigate back out of this corner and cross all the way to the other side. Every time Poppit stops, she is checking for a wall ahead of her to prevent collisions. She detects it and turns. You will notice that some of Poppit's turns are much jerkier than others. This jerkiness in the movement comes from the PID control in her IR sensor algorithm. In order to maintain a set distance away from a wall or corner, the PID controller changes the drive servo speeds of the left and right wheels. This change may lead to suboptimal speed combinations, or even temporary stoppage of one wheel, causing jerking. Back out in the center of the maze, Poppit is heading toward the far corner. She veers slightly to the left in this straightaway, to avoid hitting the right side wall, and to land more comfortably in the center zone of the upper part of the maze. Poppit is again preparing to use her IR sensor to pivot around this wall. Notice the jerkiness in her movement. However, she maintains a fixed radius from the edge of the wall, enabling clear turning regardless of the maze conditions. Here, Poppit will use internal odometry to turn, producing a far smoother result. However, this type of turn cannot respond as effectively to changing conditions in the maze or different terrains. Poppit has reached the charge station, and her arc reactor is fully powered for blastoff. She must now find the blastoff station, located in the upper left corner of the maze. Again, she's using IR wall following to navigate out of this corner. To make the final turn around this last wall, Poppit will use her sonar sensor instead of the IR rangefinder to do wall following. Notice that the front sonar sensor turned to the left to detect the corner point and maintain a set distance from it. Because sonar is inaccurate at very close range and it's difficult to bounce off to sense a point, Poppit moves jerkily despite averaging her values in sets of 5. She has cleared the final wall though, and now must simply find her way to the charge station in the far left corner. She will reach the blastoff station and stop, ready to return home. Congratulations, Poppit.